Okay, we're live. All right, so I think first we're just going to look at some review-ish type of stuff on polynomials. So what is a polynomial? Sometimes like in pre-calc, I hit you with like the formal definition of a polynomial, but let's kind of keep it informal. I don't think we need to know the formal definition yet. So, in fact, you might never need to know it really. So it's not a good start. So let's say what a polynomial is kind of informally. It's not perfect, okay? So what is a polynomial? Oh my gosh. Polynomial. Okay, so I'm going to say it's just a sum or difference of monomial terms, so we need to know what those are, but that's pretty simple. Each having only, so a monomial is like a term, like x squared is a monomial, for instance, or even just like x, that's a monomial, or 2x, or 7x squared, or pi x squared. Those are all monomials, one term, right? The key to be a monomial is that you only have positive integer exponents. Okay, and later this week we're going to hear another word for a monomial, so I'm just going to put that up there right now. Another word for a monomial is, and I like to use this vocabulary a lot in calc, is called a power function. Okay, so power functions are going to be something that we add to our list of functions that we have for the year, right? Like what kinds of functions do we have so far that we've learned? Linear, quadratic, exponential, logarithmic. That's about it. There was one that we barely did a tiny bit. Absolute value. Excellent. So we've got about 5 so far. Power functions are going to be our next ones. And a parabola is a power function. It's just one specific type of power functions. Power functions are pretty easy though. Okay. Polynomials, when you start to combine power functions, they get a little bit trickier, but we'll see what happens. So what are some examples of polynomials? And then what are some things that are not polynomials, so non-examples? Okay, I thought we'd just talk about that first. And I don't think the book has very tricky problems. I wish they were trickier actually, but it's okay. So something like 3x squared minus 4, what is that? It's a polynomial, but it's also a parabola. It's just a combination of two monomials. What about this one? It doesn't even have an x. Is that technically a monomial?
Yeah, because it's x
to the
0.
X to the 0, that counts too. So I should put positive or 0 exponents, right? 0 works too, okay? Or you could say the natural exponents. That's another way to say that, different ways to say it. Anyway, so there's an example, but there's also things we haven't seen yet. Things like maybe a half x to the 7th power. That's a power function. Now if I add another term, now it's a polynomial. Okay, so it's like two power functions combined. I could add as many terms as I wanted, but we haven't really studied x to the 7th yet, have we? So that's our goal, is to start looking at things like that. Okay. Also, maybe if I change the variable, go like this. Is there anything that makes that not a polynomial? Is t okay? It's t to the 1. Katie just said 2 is like 2t to the 0. And this one is t to the cubed. Just because it has a pi in front of it, something that's irrational, the coefficients don't matter. Like they can be anything. Coefficients can be rational, irrational, fractions, integers, anything. Okay? What are some things that are not polynomials though, just for some contrast? Can you give me an example?
3x to the negative 2 minus 4.
Yeah. So she took that first one and she made it slightly not a polynomial. Why?
Because it's raised to a negative power.
What's this mean really? If you rearrange this, what's negative power mean? It means fractions. So that's really 3 over x squared, isn't it? Is that the same kind of thing as like a parabola? The x is on the bottom now. That's something totally different, which we're going to learn about. That's what we'll do next unit. But it's definitely not a polynomial. It looks way different if you graph it. It's a totally different thing. Okay? But you can see it's clearly not the same kind of thing as this. It's a fraction. Yeah? Okay. Something else. There's all kinds of things that aren't polynomials, of course. Like this. What is that?
3 raised to an x, that's
That's an exponential. We know how to do that, but it's definitely not a polynomial or a power function. Power functions have solid exponents, not variable exponents, okay? Maybe something like this. We're going to do these soon too. That's not a polynomial.
because x
I think that's
has-
pretty clear. Did we already talk about this? We've mentioned it like once or twice. What does root really mean, exponent-wise?
Negative, no, to the half.
Negative means on bottom.
Half.
It means half. And I know a lot of you guys don't know that yet, and that's okay. But is that a positive integer? No.
Yeah.
Is it? It's an integer? It's a counting number? No, it's a rational number. It's a fraction, but that's not a polynomial, is all I'm saying. Okay? If you had something like this, that's not a polynomial. Why? Where? That. If you just had this piece, would it be? Yeah. All right. So polynomials we like to kind of deal with in a standard way. So let's look at what that is. So you should always pretty much. Sometimes they won't come this way, but when you start working with them, you should rearrange them. Okay. So polynomials should
Have the highest exponent first and
Yeah.
then go down. Like if you had the exponents as 2, 4, 7, 8, and 10, you'd put the highest one first and then you move down.
Yeah, you guys are okay. You should think with the highest one first. That's called descending order. Okay. From the highest thing. Great. So maybe we should do 1 or 2 of those.
From
So-
T6.
Yeah, this is too easy. Make a harder one. Let's do this one first. Yeah, this is good. There, I tried to make it a little harder than your problems. Otherwise, this is just too boring. Okay, this guy. Let's put it in descending order and then use some vocabulary and name some stuff. So what should go first? How many terms do I have first of all? Okay, which one should be first?
4. The pi x squared, pi x.
That's the highest degree thing, isn't it? Because it's got the highest exponent. When I say degree, I'm talking about the exponent, okay? So we're going to say pi x to the 4th, it's positive, right? And then,
Plus 3x squared minus 4.
okay, that's in descending order. That's the way we like it. A couple pieces of vocabulary. You might get asked for what's the degree of this polynomial.
It's the highest power.
So 4. Yeah, right there. That's what degree means. It's the highest power that you can see. And leading coefficient. Coefficient, what's coefficient mean? Can somebody tell me? Ah, it's like the number in front of the variable. Excellent. So what's leading coefficient mean then? The first one after you put it in the right order, right? So the leading coefficient on this is pi.
Oh, I didn't see it.
Okay? So I'm going to say leading coefficient. You can abbreviate, that's fine. We'll say it's pi this time. Once again, it doesn't have to be any specific kind of number. It could be a decimal, it could be an irrational number like pi or square root of 2, it could be anything. Okay? But it's still a polynomial. All right, this one. A little tougher. Help me rearrange it. How many terms again?
3.
Oh, 3. I shouldn't pick something else to make it more interesting.
Well, what if like E is a trillion and like X is a million or something, and E has a set value
There. Okay, that's a little more interesting. How many terms now? 4. Remember, things like this don't have to be difficult. If you know polynomials, I could try to make this as hard as I want, but almost everyone in here is still going to be able to understand it, if they don't get intimidated. Yeah?
I'm not intimidated. I know the answer.
What is first?
2 sevens, negative 2
How do you say that?
Negative,
Square root
negative
negative
2
2
sevens.
I always say negative root 2 sevenths or negative square root of 2 sevenths. Yeah?
And then
That's got the highest degree, so it's going to come first. Then what? Careful.
then it will be e squared
Okay,
times
Katie's saying this one, right? You guys hear her? Maggie, which one did you say? It's one of
No.
those two, isn't it?
No,
It's gotta be
it's not
one of
the
those
second
two.
one because that one's a number because you know what it is
Negative.
because it doesn't have an X in it. You know what that number is.
How about if I replace this with the other multiplication sign? I meant multiplication sign there.
It's negative.
That's scientific notation, isn't it?
Yeah, so that's
Does it have a variable on it?
No.
So that's really just the thing at the end, isn't it? That's the constant at the end.
So they have a 1 exponent?
So it does. It has like not a 1 exponent, but
Zero.
it's kind of like we could put what on here? X to the,
0.
if we wanted to. Good. Okay, so we got this one. Then we're going to put this one. We've seen E before, right? What is E?
Like 2.7 something.
2.718.
Yeah.
It's like pi, right? It's our other most famous irrational number. Okay, so we got that one, then what one next? The squared one? Okay. And then finally this thing, this is just some number, right? It's a big or small number?
It's a big small number.
It's a negative. It's a small number. It's really small.
Oh, okay, so magnitude-wise, is it a big or small number? Magnitude-wise, it's big, but where is it? It's way down there. Good, you guys keep me honest. Good. Okay, so a little vocab practice on that one. Degree? It's easy, right? What is this? It's 1,000. Leading coefficient?
That negative 2
root.
Whatever that is, right? The constant term would be that thing in scientific notation, which is like how big? Tell me how big this is approximately.
It is.
See,
It
this
can't-
is useful for
Wait,
physics.
it has to be a .1403. That's not possible.
That's a comma, right? It's 14 or
But I
1,400.
didn't think you could do it like that. That had to be a number between.
It's
1
not
and
in perfect notation. You're right.
10. Okay, then it'd be that number followed by 7
So,
zeros.
can you guys tell me what order of magnitude, what power of 10 is this? About 10 to the what?
10, right? Because you have to move it 3 over.
Good, good, good. 10 to the 10th. But what is just this piece? This is key for science. You don't know any science if you can't do this kind of stuff. This is 10 to the 3rd, and then you've got 10 to the 7th, right? This is approximately. So Maggie said that's about 10 to the 10th, which is how big?
10 with 10 zeros.
About 10 billion. Good. Because 3rd is 1,000, 6th is million, 9 is,
Billion.
12 is,
Trillion.
and it's between those, right?
15 is.
Okay. Good to know some science. All right, so that's stuff you guys have seen before, I know. So let's combine some polynomials just with adding and subtracting and stuff. You know, you guys have done this before, but just make sure. So do some combinations. This stuff can get long and kind of messy, but it's pretty easy. Watch your minus signs. Okay, let's start with those. So these are just combining polynomials different ways. I know you've done it before.
Is there some kind of trick with this?
Like what?
Because I think with Mr. Parsons, did we do some kind of.
Did you? Maybe you
I don't
did.
remember. Maybe not. Maybe
There's all kinds of tricks you can learn for stuff. I don't like tricks though, because then I forget the trick and then I can't do it. So, okay, there's one dangerous thing here. This is one of our fundamental. Remember, we had that page on the front of our notebook that says things you really don't want to do. Where's the dangerous thing in this? Can somebody spot something that could go wrong? This. I mean, I have my calculus students do this sometimes still. I get so frustrated. You got to distribute that minus, right? That's the only thing that could really go wrong here. So this one, do we even really need the parentheses? Can't we just drop them? The only reason these parentheses are here is to clarify that you have this degree what? Degree 3 polynomial being added to this degree 3 polynomial. Yeah? That's the only reason they're there. Otherwise, we can just erase them right away, can't we? And just start doing what?
So you
Like
have
terms. What's together? This is just Sesame Street.
3x
Ones of these are the
cubed.
same, and which ones of these are?
3x cubed. Which would be
3
Yes, that's right. 3x cubed. Okay.
plus 5x squared plus 6x plus 13.
Is that right?
No, it's
Because 7 minus 1x, 7x minus 1x is 6.
I think it's good. On this one, I encourage you all to write out this distribute step so you don't miss it, especially when you're this age. Maybe later on you won't need it. But right now, don't be too skippy. Okay? Questions?
no, we're playing mathematics.
Oh, okay. Okay, what do we get on that one? Like terms, are there any x cubes? No. Any x squareds?
Yes.
2 of those. How many of the 2 terms?
3x.
Negative 3 of the x squareds. X's, we just have that term, so just that.
Minus 3.
And then we have 3 minus 6 is minus 3. Done. Okay? This one, instead of adding or subtracting the polynomials, I am multiplying them. And we know
So
how to
a
do that.
times it, then 3, negative 3 times it.
So you can color code it if you like. Just don't forget one. You've got 3 terms there. They're going to pop out. That's not all though, right?
2a minus 5a squared.
You've got 3 more there. So you should have 6 terms. Maybe some of them will smash together later, but that's where we're starting. Yeah? So let's keep this in colors. So the red ones, what are we going to have? I want some other people answering. Anna, you tell me.
A squared.
For red?
Negative 5a squared. 2a cubed.
A cubed. Cool. Ben, can you tell me the green ones?
Yeah, you have 6, then negative 16a, and then 3a squared.
Almost. Start over.
Oh, it's negative 3. So negative 6, 15a, and then negative 3a squared.
Sweet. Good. And then can we stick any of those things together? Sure. A cubes, we've just got the a cubed, right? A squareds, we've got this and this. So you can circle stuff to help yourself out, whatever you need to do. So we've got how many a squareds? Negative 8 of those. And then a, we did this one. Then 17 a's and negative 6. There we go. Descending order, set, ready to go. We could say it's degree 3, leading coefficient is 1. Constant term is negative 6. Great. Okay. 1 or 2 more, and I think we'll stop for today. This should be this review. You guys have done this before, right? Okay. Good. Good to review it though. We don't want to miss those negative signs, so be careful of that. Let's do 1 more, then we'll do a couple more tomorrow to warm up. This is a big one for this unit. This is one of our key focuses, is being able to expand problems like this one. There's long ways to do it. There's really short ways to do it. I'm assuming you guys may have actually seen the short way. Did Mr. Park show you Pascal's triangle?
Yes, but
Good.
yes.
So we'll review how to do that as well. I like Pascal's triangle. It makes this problem come out right away and it's done.
Usually
Let's
we
do it the
go
long way
A
though.
plus 2b.
Yeah. That's what we're gonna have to do for now. Important to be able to do this though. But my calculus students don't like doing this. They always use Pascal's triangles. That's our goal. Not today though. For now we're just going to write it out 3 times, right? It said cubed. What if it said a plus 2b to the 7th power? Could we do it?
Yeah.
Would it be awful?
Yeah.
So in that case, would we want to use Pascal's triangle and just write the answer right away? Yeah. It'd be a little tricky still, but you can see after it goes beyond 3, you don't want to do this. So how do I go from here? Last problem for today. Just start with 2 of them and ignore 1? Okay. Could you start with these 2 or these 2 or these 2? Okay, let's just cover this up. So we're going to expand these out. So we got an a squared. Then we've got what else? 2ab from like those 2. Use your fingers. And then 2ba, but that's really just another 2ab, isn't it?
That
Commutativity.
equals 4AB.
4b squared. You can't miss those little squares and stuff. If you do, this is totally wrong and you might as well not have done it. So that's the key, is that you don't miss the little things, the little details. That's all that matters, okay? In calculus, who do you think is good and beyond? Like when I say calculus, I mean all engineering and science level math, yeah? Like anything, from basic to advanced. Who is good at calculus? People who can do this without messing up. There's almost no other hurdles to get over. That's it. Calculus, you start to use this to do some really cool stuff, but you have to be able to do this. If you're missing a squared, for instance, right here, and you follow that through and you finish your calculus problem, and it's wrong at the end. I mean, you don't want to have that issue. Yeah? So the time to get good at that is right now. Okay, so combining stuff, we've got 4 ABs, don't we? Of course, there's a shortcut formula for that. I'll do that with you tomorrow. I use all kinds of shortcut formulas. I don't write all this stuff out. Yeah? Okay, but now what are we going to have to do?
A cubed.
It's like that problem we just did a second ago. So how many terms are we going to have at the beginning? 6, isn't it? Like 2, 4, 6. So let's see what we get. So let's see. I'm going to go down rows. So Gloria, can you give me the first 2 terms?
A squared? Not A cubed.
And then
AB, no, 2AB squared.
close.
Cube? I don't know.
2. You got a 2, and then you got a squared, and then you've got a good. Awesome. 2a squared b. It's hard to say that, yes. All right, let's see. Who else? Miss Pitzer, can you do this middle one on both those?
Okay, so you have 4AB squared? No.
Where's the squared go? It's the key.
Oh, 4A squared would be.
Excellent. And
Would you just multiply that? So would it be 8? 8AB or 8AB squared?
yes, good. And I like what you said. You said 8ABB, which is b squared. That's what we're all supposed to think. That's right. Okay, let's see. Miss Maroney, can you handle finishing it? We're going this guy, right?
Okay, 4b squared A.
Okay.
And 8b cubed.
Yep. See, in things like this, I know a lot of you are going to want to do this. What would have been better to write there right away if we could have? 4ab squared and kind of keep things in the right order.
I'm doing it differently because it makes more sense for me to go A all the way through.
No,
and
this
then
is definitely,
B all
it
the
does
way
make more sense, but so you want to try to twist yourself so you can go that further step later on. No, great. Great, great. Okay, combine stuff that's the same. What do we have that's the same? I don't know how much stuff. Is there any other a cubed stuff?
No.
And you might want to cross stuff out as you go. So I'm going to say no. A squared b stuff. Do we have a squared b stuff anywhere else? Here and
Right there.
6 of those a squared b things. Does that make sense? That's the way you want to think about this. Sound like Sylvester, it helps. So then we say we got those out of the way. You got to search the whole list though. They might pop up somewhere else sneakily. So then anything else? Any a b squared things?
Yes.
This one and this is really the same, isn't it? If we turn it around, that's what I was talking about a second ago. So there's how many of those?
12.
And then we've got just some b cubed things, 8 of those. That's it. Pascal's triangle, though, generates that from just looking at this. So it's pretty nice. So we'll learn that again. Okay? Yes, that's in standard form. Definitely.
That's not.
What about the b cubed? Shouldn't be up front?
Oh, standard form does have like the cubed things up front too. I like to look at it like this though, because it's kind of got the a's descending cubed, squared, 1, 0, and the b's go up from the other side, cubed, squared, 1, 0. That's the way that it comes out of Pascal, and that's you'd probably want it in this form. Standard form is overrated sometimes. But you guys are good at keeping me honest on that one. Okay, let's stop there. So we'll do some a little bit newer stuff maybe tomorrow.